pH is a measure of alkalinity or acidity of a solution. In this analysis, we are trying to find out if the solution is acidic or basic. pH of solutions ranges from 0 to 14, with 7 being neutral, 0 to 6.9 being acidic, and 7.1 to 14 being basic. The acidity of solutions increases as you move from 7 to 0. That means acidic solution that has pH of 1 is stronger than an acidic solution that has pH of 6, while the alkalinity of solutions increases as you move from 7 to 14. That means the basic solution that has pH of 14 is stronger than the basic solution that has pH of 8. There are various methods used to determine pH of a solution, but sugar laboratories prefer using electrometric method. In this method, pH of a solution is determined by meter, which measure amount of hydrogen ions or hydroxyl ions in a solution. A solution that contains more hydrogen ions is referred to as an acid, while a solution that contains more hydroxyl ions is referred to as a base. The pH meter has a voltmeter attached to a probe. The probe has glass sensor electrode and a reference electrode. The sensor electrode is designed to respond to changes in hydrogen ion concentration, while reference electrode provides stable electrode potential. The sensor electrode is filled with a pH buffer, while the reference electrode is filled with potassium chloride solution. The sensor electrode bulb is coated with metal salts and silica, forming a porous glass membrane. When the probe is immersed in a solution, hydrogen ions accumulate around the glass electrode to replace the metal ions from the bulb. This exchange of ions generates electric potential or charge at the sensor electrode. Voltmeter measures the potential difference between the sensor and the reference electrode and display those results on meter glass as the pH of the solution. Increase in acidity of a solution has a greater concentration of hydrogen ions that increases the voltage. This increased voltage decreases the pH reading in pH meter, while an increase in alkalinity decreases the hydrogen ions concentration, hence reduce the voltage leading to increase in pH value in voltmeter screen. pH of samples from sugar factory are measured in order to control sugar loss due to hydrolysis, caramelization, or inefficient clarification. Requirements for this analysis are: we have pH meter, next measuring cylinder, next beakers, next weighing scale, next spatulas, next buffer solutions, i.e. buffer 4, 7, and 10. Next we have samples. In previous videos on sugar technology, I informed you that sugar processing has several sections, i.e. milling section, juice treatment section, evaporation section, pan boiling, and centrifugation. So in each section, we have samples that are picked for pH analysis. So for example, at milling section, we pick first expressed juice, last expressed juice, and mixed juice. At juice treatment section, we pick lime juice and clear juice. At evaporation section, we pick syrup. At centrifugation section, we pick final molasses. Then finally, after sugar drying, we pick sugar sample. The final requirement is distilled water. The first stage of pH analysis is samples preparation. For juices, you have to sieve and cool to temperatures below 25 degrees Celsius. And for syrup, you have to dilute in the ratio of 1 to 3 with distilled water. That means if you have 100 grams of syrup, you mix with 300 grams of distilled water. For final molasses, you have to prepare 10%. That means if you have 10 grams of final molasses, you mix with 90 grams of distilled water. For sugar, we also have to prepare 10% sugar solution. That means if you have 10 grams of sugar, you mix with 90 grams of distilled water. After preparing these samples, pour each prepared sample in separate beakers. After preparing the samples, the next stage is calibration of pH meter. pH meter is calibrated by placing the probe into 3 buffer solutions, i.e. buffer 7, buffer 4, and buffer 9 or 10. Calibrating the pH meter is important to ensure that the probe has not drifted off or is damaged. Buffer solution is able to neutralize small amounts of added acid or base, hence can resist pH changes. Below is the procedure for calibration of pH meter. Switch on the pH meter, give it time to warm up before start using it. Remove the probe from holding solution and clean it with distilled water. Place the probe in buffer 7, then click calibration button. Buffer 7 must be done first to clear the other previous calibrations. Allow the pH reading to stabilize. When reading is stable, the confirm tag appears. Click confirm button. The meter will display the calibrated value and the next buffer value expected. Rinse the probe with distilled water. Place the probe in the next buffer and stir gently. Allow the reading to stabilize, then press confirm key. Again, rinse probe with distilled water. Place the probe in final buffer solution and stir gently. Allow the reading to stabilize and press confirm key. The third stage is to measure the pH of samples. After calibrating the pH meter, wash the probe with distilled water. Place this probe in the first sample. When you place the probe in the sample, the meter will automatically start to read the pH of the solution. Allow it to stabilize and record the pH displayed on the screen of the meter. Remove the electrode from the sample, rinse it and place it in the next sample. After analyzing all the samples, clean the probe with distilled water and place it back to storage solution. Below are expected results or critical limits for each sample. That means if an analyst gets results that are beyond the given limits, there must be corrective measures that have to be applied in order to control losses that might occur due to pH deviation. The first samples is milled juices, and under milled juices we have first expressed juice, last expressed juice and mixed juice. The critical limits for these juices is between 4.8 to 5.5. The next sample is lime juice. The critical limit for lime juice is 8.0 to 8.4. Next is clear juice. The critical pH limit is between 7.0 to 7.4. The next sample is syrup. The critical limit is between 6.7 to 7.0. Next is final molasses. The pH limit is between 6.0 to 6.8. And finally we have sugar. The pH limit is between 6.8 to 7.0. Extracted juice from sugarcane has acids like phosphoric acid and amino acids. The presence of these acids in juice make it to be acidic in nature. The pH of extracted juice ranges from 4.8 to 5.5. In case the pH of mixed juice is below 4.8, it shows that fermentation is taking place at milling section, i.e. lactobacillus microorganisms are breaking down sucrose to lactic acid. This high acidity can lead to further hydrolysis, hence more sucrose loss. Hydrolysis is just breakdown of sucrose to fructose and glucose. The corrective measure for this deviation is to increase biocide dosing at milling section. The function of biocide is to kill microorganisms that consume sucrose. Lime juice is basic because calcium hydroxide is added to juice extracted from sugarcane at juice treatment section. This calcium hydroxide raises the pH of juice from 5 to 8. The function of calcium hydroxide is to neutralize acids like phosphoric acid, forming salts like insoluble calcium phosphate. Insoluble calcium phosphate precipitates out with other impurities, settling down on clarifier with the aid of flocculant. Neutralization process lowers the pH of juice from 8 to 7. That's why the clear juice that remains at the top of the clarifier has the pH of between 7 to 7.4. pH of clear juice below 7 and above 7.4 should be avoided because this extreme pH lead to hydrolysis and caramelization respectively. Hydrolysis is just the breakdown of sucrose to fructose and glucose in presence of acid and high temperature, while caramelization is the conversion of sucrose to brown compounds in presence of high temperature and alkaline condition. These two reactions lead to a reduction in sucrose in extracted juice. The pH of lime juice and clear juice can be controlled by either reducing or increasing dosing of milk of lime or calcium hydroxide. pH of syrup and final molasses is slightly lower than clear juice because during evaporation, most of salts precipitate out of solution and fall on the surface of tubes, leaving more acids like aconistic and amino acids in the solution. Pure white sugar is an ionic compound, i.e., does not dissolve into ions when added to water. Sugar does not release hydrogen ions or hydroxyl ions when it dissolves in water, so it doesn't alter the pH of distilled water used. And remember, the pH of distilled water is 7.0. So when you prepare sugar solution of the solution of pure white sugar, the pH of that solution will be 7.0. But brown sugar is slightly acidic because it has a layer of molasses, and remember, final molasses is slightly acidic. Alkalinity or acidity of a solution can also be measured by indicators like phenolphthalein and litmus paper. But these indicators are not accurate and cannot give exact pH value of a solution. That's why sugar laboratory prefer using electrometric method to measure the pH of a solution.